Welcome. In this video I'm going to show you how you can perform a power divergence test of goodness of fit using Microsoft Excel. I have a separate video where I actually show you how you can do this with my add-in stikpet E, because if you've installed that you can simply use the function for it and it will actually give you all the results that you probably need. But in this video I'll assume you don't want to use any library, so we have to do the works because there's no simple function for this in Excel. I have some example data in column A, taken from the General Social Survey, I think from 2012, adjusted a little bit for example purposes. I'll focus in this video on how to actually perform the test, not if you should be using this test or all the details on interpreting the results. We need to set a lambda because that's something this test requires. There are a few values that are sometimes used and then it has a specific name. I think if you use 2/3 it's called a Cressie-Read test, but there are different values you can choose. Then I'll simply select all the different categories. If you don't know them, there you can actually do a copy paste of all the data, paste that somewhere else, and then select that column and then go for data and then remove duplicates. Then I'm going to count for each of them in the data the specific category. So and then I can just drag this down or copy paste it down and see that, for example, there were 79 people who selected separate. In total, I had a sample size of 1941. Then the number of categories is 5, so I can simply count all the frequencies. And I'm not going to set any specific expected count, so I'm going to be using the same one for all. And in that case, I'm simply going to take the total sample size and divide it by the number of categories. Then I need to check the conditions, or at least that's recommended. The percentage of cells with an expected count less than 5 should, some say, be 0% in these cases. So some will say 20%. Of course, there's only one, but all of them are indeed above 5, so 0% is the number of cells with expected count less than 5. The minimum expected count is in this case the only expected count and should usually be above 5. Then the degrees of freedom is simple, the number of categories minus 1. And then comes the big one, which is calculating the chi-square value. Now there are 3 different formulas actually, depending on your lambda value. So if it's 0, you use this one. If it's -1, you use this one. And otherwise you use this scary one. So we have everything of this. This is the observed count. The EI is the expected count. And ln is the natural logarithm for which Excel luckily has a function. So I'm simply doing an if lambda, which was in E7, equals 0, I take the observed count and multiply it with the natural logarithm of the observed count divided over the expected count. Otherwise, if lambda equals -1, we get that second one. I actually take the expected count and then do the natural logarithm of the expected divided by the observed count. Lastly, I take the observed count and multiply it with the observed count divided over the expected count raised to the power of lambda -1. So this is exactly that big part over here, or almost. I do this for each category, so I copy pasted it down. And last but not least, if it's a lambda is 0 or -1, it gets multiplied by 2, and otherwise 2 divided by the lambda value times the lambda value plus 1. And finally, we can then determine the p-value. That's the one we're mostly probably interested in, which is the chi-square distribution, right tail of the chi-square value and my degrees of freedom. In this case, it's below 0.05, which is the usual threshold. So we would reject the null hypothesis and claim a significant result in this case and say that in the population, most likely, the counts will not be equal for each category. Alright, I hope this video was helpful and thank you for watching.